Hi guys, welcome back to my channel. Hope all you are fine. Today's discussion regarding the latest questions for CSWIP 3.1 Welding Inspector. This is the part 11. So you know the part 10. There are total 10 videos are there regarding the CSWIP 3.1 Welding Inspector. So you can go through that all the parts. So you can get a good knowledge regarding these questions and answer with the explanation. So let's start. Before we start this video, so I want to say one thing. This is my YouTube channel, http what is mentioned www.youtube.com/welding NDT inspection. So still people are not subscribe my channel. Please go through this channel and subscribe to get the regular updates and regarding the welding and NDT inspection related question, piping, pipeline. So all these questions you can go through from this channel. So please like this channel and subscribe and share. How to share? You see here the share logo is here. You can see here the subscribe. So you can subscribe this channel to get the regular updates. So let's start. The first question is, one of the following alloys is non-magnetic, which? So this is the options. Option A is 4% chromium molybdenum. Option B is 12% chromium. Option C is austenitic stainless steel. Option D is 9% nickel steel. So this is the question is non-magnetic. So the non-magnetic, you see here the type of stainless steel austenitic grade. Alloys with chromium and nickel. Example 304 and 316. 18% chromium plus 8% nickel. That is for 304 and 316. Main phase is austenitic. Very wide range of application. Very low temperature service. Cryogenic. High temperature service. Moderate corrosion resistance. Non-magnetic. So definitely you should know the stainless steel is the non-magnetic steel. So this is the austenitic stainless steel is the correct answer. The option C is the correct answer. So understand the question number 1 answer will be the option C, austenitic stainless steel. Now we'll go for the second question. Second question is, when TIG welding austenitic stainless steel pipe argon gas baking is called for, this is two. So when TIG welding austenitic stainless steel pipe argon gas used, why? Why we used in austenitic stainless steel argon gas for baking? First is the prevent oxidation. Option B is prevent underbead cracking. Option C is prevent porosity. Option D is the control of penetration. So you should know very well why argon gas baking is needed. Because of stainless steel pipe is there. If it is argon gas is not baking is there, so it will happen with oxygen and the stainless steel will be formed and there may be corrosion. So you see here there is the most important part, oxidation of SS weld bead or root by poor gas cover. In this case, that's why we need the argon gas for baking. Most welding defects with TIG are caused by the lack of welder skill, incorrect setting, and that is current, torch, manipulation. You can see the welding speed. So tungsten inclusion, surface porosity, catter pipes, oxidation of SS weld bead, root concavity, and lack of penetration. All these things are happened the austenitic stainless steel, this type of defect you can see. So correct answer will be the prevent oxidation. We use this argon gas because of prevent oxidation. If oxidized, then it may be corrosion in future. So answer is option A. Question number 3. The principal purpose of a welder qualification test is to. What is the purpose of welder qualification? First is the test the skill of the welder. So you need to check the skill of the welder. Definitely this is the most important things we use for welder qualification. Assess the weldability of the material. Never. And we cannot see in the welder qualification only for the weldability. Weldability you can see and the production weld. Decide which NDT methods to use. No. Welder qualification test we are using for the welding, not for NDT. Give the welder practice before doing production welding. No, we are not giving to any practicing to the welder before doing production welding. So he should approve by the inspector. That's called the welder qualification test. So he should skill. The answer is simple. One question is there. What is the main reason of qualifying a welder? To show that he has the skill to be able to make production weld. So you understand now. Answer will be the option A. Question number 4. A fabrication procedure calls for the toes of all welds to be blended in by grinding. The reason for doing this too. You see in fabrication procedure or in fabrication inspection, you see in the fillet weld some toes or in the bar weld that is toes, you should be blended in by grinding. There should not be any sharp edge. Why? Make the weld suitable for liquid penetrant inspection? No. We are not using for only this one for. Definitely we are using for, we can blind it for the liquid penetrant inspection, but this is not the right answer. Improve the fatigue life, reduce the residual stress. Definitely this is also one will be the answer, but we cannot see this one is the right answer. So we have to check the what will be the right answer. Improve the general appearance of the weld. So there is two answer will be there. One is B, another is residual stress. You can, if it is right here, the stress concentration, definitely that can be the one answer. But here another good answer is there, improve fatigue life. If there is no stress concentration, definitely improve the fatigue life. So this will be the right answer. No. So you see here, this is the 80° after the, this is means poor weld toe. You see the 20° means this is the improved weld toe blind angle. Most codes quotes that weld toe shall blind smoothly. This statement is not quantitative and therefore open to individual interpretation. So you see this is not a quantitative, so it is open for the, you can, individual interpretation will be different. The higher toe blind angle, the greater the amount of stress concentration. So I already told the stress concentration means the higher angle means stress concentration is more. If the lower angle, the stress concentration is low. So stress concentration is low means the improve the fatigue life. The toe blind angle ideally should be between 20 to 30°. So answer is option B. Question number 5. For full penetration single-sided bar joint, root bead penetration and profile are mainly influenced by. In the question there is answer. You see here. For full penetration single-sided bar joint, root bead penetration means welding in the root, in the penetration in the opposite side you have to check. So what is the mainly influenced by? Root face, bevel angle, root gap or included angle. So definitely if there is no root gap is correct, you cannot get the full penetration of single-sided bar joint. So correct answer will be root gap. This is not the right one. Included angle, no. So root gap is the correct one. You see here, butthole size, weld cap width. This is the root bead width. The root penetration is here. So if there is root gap is not the actual as per dimension, as per WPS or as per specification, definitely you cannot get the penetration. You see here root gap. Root gap, you see here the root gap. Allow control root fusion, reduce the disc of burn through. So root gap, if it is controlled, then it reduces the disc of burn through. You see, too large root gap, it will happen the burn through. Too small, you see lack of root penetration could be generated. So you understand the what will be happen in root gap? If is root gap it is small or root gap it is big, large, then everything will be problem. If it is too large, then it will come the burn through. If it is too small, it will come the lack of root penetration. You see root face. You see allow control root fusion, reduce the risk of burn through. If you see the root face is small, so it will happen the burn through. Root face is very big, then lack of root penetration will be there. So answer will be the, you understand, answer will be the option C. Question number 6. Which of the following would be cause for rejection by most fabrication standard when inspecting fillet welds with undercut a small amount of? You see, there is a rejection in most fabrication standard when you are inspecting a fillet weld and you see an undercut. Why it is rejected? What is there? That's why it is rejected. So there is two things, that is A, B, C, D. Four option is there. One is depth, second is length, third is width, another is sharpness. So depth it can be accepted because of there is acceptance criteria. In the length also acceptance criteria, in the width also acceptance criteria. So these three things, it is not the correct answer. You see, this is not the correct answer. But sharpness, if there is a sharpness in the undercut, what will happen? That area will be stress concentration. So sharpness should not be there in any undercut. You see here the size effect is reflected by the loss of cross-sectional area, which is insignificant when compared to the shape effect. So the main conclusion you see here, it is mentioned high stress concentration is expected when the toe radius of a flat fillet or tip radius of an undercut is very small. An undercut with relatively large tip radius does not necessarily mean higher stress concentration than the encountered with the flat fillet having sharp toes. So sharp toes definitely have the higher stress concentration. So answer will be the option D is the correct answer. Question number 7. When visually inspecting the root bead of the single V-bar weld, it should be checked for. So you are checking or you are inspecting a root bead of the single V-bar. So what you need to check? Lack of root penetration, hedge hardness, tungsten inclusion or slag. You cannot check the hedge hardness. This is to be checked by Vickers hardness or Brenner hardness. Tungsten inclusion you have to check by radiography. Slag you have to check by the radiography. So the lack of root penetration only you can check when single V-bar in root bed checking, root bead checking. So the correct answer will be, see, this is not the correct one. Correct answer is the lack of root penetration, because this is the visual inspection. First you have to understand this is the visual, so we cannot check hardness, internal slag, tungsten inclusion. So correct answer is option A. Question number 8. The strength of a fillet weld is determined by. This is a very important question. The strength of the fillet weld is determined by in leg length or throat thickness. Which one? You see, just given one example, importance of the fillet weld leg length size. You see here, this is 4 mm fillet. This is 4 mm fillet. So also another one you see here, this is 8 mm fillet leg length. Another is side 2 mm. But you see here the cross sectional area both are same, 4 into 4 16 mm square, 8 into 2 16 mm square. So the main important thing from here to here, the throat thickness. If it is throat thickness not as per the equation 0.707a, so you cannot get the actual throat thickness. So approximately the same weld volume in both fillet weld you can see here, but the effective throat thickness has been altered, reducing considerably the strength of weld B. Weld B is the throat thickness is less, that's why you cannot get the correct strength here in this joint. So the very important thing is the correct answer will be the throat thickness. Option D is the correct answer. Question number 9. The European standard for ND of fusion welded by visual examination is. What is the code? EN288, EN499, EN287, EN970. This is the very basic question, but we should know for this. This is EN970. You have to blindly, you should know this one, EN970 for this fusion weld visual examination. See here, BSEN 970 is the non-destructive examination for fusion weld visual examination. Welding inspection personnel should be familiar with the relevant standard. B is the inform about the welding procedure to be used and have a good vision. These three things is very important in BSEN 970. The answer is D, option D. Question number 10. Visual inspection of a fabricated item for a high integrity application should cover inspection activities. So you are doing a visual inspection in a fabricated item for a high integrity application, maybe in boiler, maybe in pressure vessel, maybe in oil and gas industry. So what should cover the inspection activity should be there? There is four options. One is before, during and after welding. B is before welding only. C is after welding only. And D is during and after welding only. So this is the correct answer. Before, during and after welding. This is the very important in CSWIP 3.1. You can see there in CSWIP book there is welding roles and welding inspector roles and responsibility. You can check there what is the inspection coverage or inspection activity should cover. This is the three things you have to do. One is before welding, during welding and after welding. Then you have to complete the inspection. For high integrity fabrication, inspection required throughout the fabrication process, before welding, during welding and after welding. So correct answer is option A. Question number 11. Incomplete root penetration in a single V-bar joint may be caused by. So you see there is incomplete root penetration in a single V-bar joint. What may be caused? Why? There is four options. Excessive root face is there. That's why incomplete root penetration. Excessive root gap is there. Definitely if there is excessive root gap, root penetration will be more. Means it can be burned through. So this is not the correct one. The current setting being too low. Maybe. show excessive root phase. If it is there, then root penetration will not be there. If there is current is low, it can be also there not enough root penetration. So the correct answer will be both A and C. You see here, root gap. You see root gap. This is if root gap is more, then the burn through root gap is small, means incomplete root penetration. You see here, too small root face, the burn through could be occurred. You see the too big root face, then the lack of penetration, means large root face, lack of root penetration will be there. So option is D, the correct answer. So I think you understand this all 11 questions with their explanation. Hope you understand all questions and answer. If you have any problem or query regarding the questions, just you send a comment or query in the YouTube comment box, then I will reply for you. Thanks a lot. Please like, share and subscribe my channel to get the regular video. Thanks a lot and take care.